Hello everyone. Uh, Please comment if I am clearly audible and visible both. Good evening. Good evening. Good evening, everyone. I hope everyone can see my screen clearly. Yes, we are going to start only if your friends or anyone who has registered kindly share, or even those who have not even registered kindly share the link so they can join and don't miss any part in this. Yes. So yeah, yeah, kindly share up screens, share the link quickly among your friends so they don't miss any part. We are just going to start in a minute. And first of all, I would like to just tell you guys some rules of this whole boot camp. Do not spam attendance will be given at the time whenever I feel right, that like last 15 minutes or 20 minutes when I will see, I will post attendance and it will be pinned in that chat section. You guys can access from there and mark your attendance. It will be open after sometimes also after the class end, so you guys get enough time to mark the attendance. So don't spam again and again attendance. As you guys know, I can have a block option also in this. Like if anyone like spamming again and again, it can be blocked. So because the relevant questions gets missed because of this spamming, so please don't spam anything. Only if you have genuine question, uh, please put your genuine question on your chat so that every question can be answered and there's no doubt left among the students. Yes, I can see like quite of you guys are active. Quite of you are active. Yeah. Again, I'm repeating, if you guys, so what like today, now I think almost all of you guys have joined session. So let's start with the AIML bootcamp. So what's actually this bootcamp is? So you nowadays you guys are looking that the amount of diseases or anything, the most common disease you name like diabetes, heart disease, and like thyroid and many more such diseases people catch very frequently. And once they age, it is very often that people like nowadays very young people also caught, but uh, after year of 30, 35, or 40, people catches diseases like heart diseases, diabetes and many more very frequently. So as you are looking around the world, AI is booming everywhere. Like you name the thing and AI is present there already. So why not in the section of medical science? So in this medical science section also, we are going to build an AI ML model in which it is going to detect all kind like diseases which can be related Here, like in this, we are going to focus on first of all, on the heart diseases. You guys can like, I will train you guys in such a way that if later on you guys can want, you can guys can pick any kind of data set of any kind of disease, and you can build a ML model upon that. So like, you have a multiple models to detect any kind of diseases through simple reports or data, which can be obtained through reports or a regular checkup. Yes. uh, I can speak Hindi, but it will not be suitable for, like, we have some international students also from like different countries and across India also. I think all of them will not be comfortable with in Hindi, so I am conducting it in English so everyone can understand easily. Okay, so coming back to this, so we are like, there's like, I think many of you guys here are from tech background or engineering background. So now or another day, there you must have faced a debate among who is greater, like, yeah, an engineer or a doctor. So to outburst that debate, we are going to like build an AI that saves the life. Like, it can, where it all can be used, we are going to talk about that, and even how it can saves life, like, because although doctors held a special place, they have a special duty, they have a very much more load on them. So we can just try to help normal people for a very initial checkup, or tell them what disease they are going to have, or the body has started to catch on. So in this, we are going to do this. And as you guys know, and why AI is booming nowadays, like, most of you guys must be having placement soon. So when a recruiter comes and asks you any question about why we choose you, if you take names of old technologies, the recruiter might not, because he has already AI tools for that. So why he should choose you? So you can proudly say that you have worked upon cutting edge technologies on AI innovations or the emerging technologies, so he can hire you. Anyway, by the way, if anyone who has not registered in the, like, properly registered in the boot camp, can scan this QR and register on this, and even in the description also the link is present. You guys can go on. So first of all, we are going to look an overview what we are going to understand over all these 5 days. And from a, like, I'm going to teach you guys in such a way that if you guys haven't built any ML model initially or previously, if you have a zero experience in that, then too you can like do this thing and get a wholesome idea from, like, getting a data set till the deployment of that whole ML model, from training and everything. Like, you guys can read here that what we are going to do. Like, here we are going to use public health data set in the um, like, what we are going to use, on which basis we are going to, so we are going to use data set, and with that we are going to deploy models predicting conditions such as heart disease or even diabetes or anything thyroid, which can be detected through the reports, or tell to the patient by the reports. So I hope by the end of this boot camp, you guys can showcase your AI professional skills to the recruiter or anyone, from like pre-processing till training and evaluating, and then real time prediction also. Even if you want, you can guys like get real time prediction. So these are our objective of our boot camp, what we mainly focus upon, like how you guys are going to work and everything. It will be like between 1.5 to 75 minutes, like 90 minutes to 75 to 90 minutes per day. And it will, this is the first day, so we are starting fresh. You guys can match the pace. Yes, free. I'm going to like have some patience. Like there's a name Animal Kingdom. Have some patience. We are going to talk about that only from like from where you guys have to get the data set, like how to train and everything, and everything. Have some patience. We are going to see everything. There's no like need to hustle or and do everything. So just a minute. Let's start. Okay. So these are kind of objective which we are focusing about. Like we are going to first of all master the fundamental, basic fundamentals of machine learning and data pre-processing. I'm like going to explain further what is pre-processing, what is machine learning, and everything. Then we are going to like build classification models based on logistic regression. Like if students from the like engineering background or doing CSE or any branch, in the first year and the second year you guys must have studied a subject name as maths 1, maths 2. In that you guys must have studied the logistic regression. So this is kind of algorithm which we mostly use in the machine learnings, and then we have advanced assemble methods which we are going to focus further. Then we are also going to evaluate the model according to like whole industry on which the machine learning industry is working about, like accuracy, ROC, AUC, and even the confusion matrix also based on heat maps and everything. So we are going to see also like what we have actually trained, how much like how much the model is going to perform when we have some kind of predictions. Then we are going to like have some insights data and how the model behave. Then we are going to like prepare a portfolio, like when a recruiter asks you what you have developed, so you have to show something what you have worked upon. Same way we will push this whole project on the GitHub and prepare a professional readme, so that you guys can work whole upon this. And a part of like in this we are working upon a simple data sets in the form of structure like Excel sheet or CSV files. But we have different kind of things, like we can even brain tumor MRI detections projects are also there. Like even the brain tumor images can be scanned and tell by the system or the machine learning models, like how it is going to uh, move further, like what kind of tumor, in like tumor also we have several kinds, what kind of tumor they have, at what stage it has reached, and everything we are going to talk about. Yes, you should do hand on hand. Like you guys can split the screen half, like YouTube screen, and on half you can open the Google Colab, on which we are going to work. If like you are having problem in half screen, then you can like I hope everyone is having mobile and laptop, same, so they can open the YouTube video on mobile and work on the laptop screen side by side, so you guys don't lag. So here is the itinerary of day by day, what we are going to proceed and how we are going to do everything. So on the day one, like today, what we are going to do, we are going to do some ML basics and data pre-processing. What is data pre-processing? Like taking a simple example in simple words, what we like if you have to cook anything, like if you have to cook a cake, then what you guys are going to do? You simply have to like prepare a batter and do the greasing and everything, then prepare the oven, preheat and everything. Same way, data pre-processing is the preparation of data for actual like operations which we are going to do. See, when we receive data, there are several issues with the data, like there are missing values, there are repetitive values, like same values repeating. So we have to kind of work upon these things, like we have to fill upon all the missing values, you have to remove the repetitive or the like duplicates value from the system, so it doesn't get confused over the same thing again and again. I think what yes, you guys will get the certificate. You are a doctor, it's very good, and you have basic coding knowledge. So yeah, you are at very right place. Here you can like get from basics to till the level of deployment. We will teach everything. Like if you are asking where I can get the data sets and everything, you are going to see everything here only. So just have some like tea and coffee and see the whole boot camp, so you guys can develop everything. Okay. Yes, if ML always scares you, I will keep it simple. What is portfolio? Portfolio is actually telling that what you have done in the field of that. Like if you are from tech background, a portfolio will tell that what you have done in that professional background and everything. Can you use VS Code? Yes, you can use VS Code or any ID, but it is more feasible. I will suggest to use like Google Colab, that because it is first of all like a global network, you can access it from anywhere, and it doesn't like put like ML kind of is a heavy programming and everything, so it doesn't put any load on your system, so you guys can do side by side. And even you can share. We will be going to do whole project in the Python. For this, you guys must have a very even the basic knowledge of Python can work, as everyone knows Python is very easy to understand. It is normal, readable English. So anyone with a basic English understanding and Python understanding can understand what actually the code means. And same way, I am going to explain the code also in very simple language, so even the non-tech background student can also understand what does it actually means. Like many students are not from non-tech backgrounds also, and they want to learn coding, so they can use. So I think let's start with our day one. And further, like on the day two we will train the model and evaluate, then we will by day we will advance the features, and then we will do hyperparameters tuning and model optimization, like we will tune more and more. And in the last day we will like do some live predictions, and then I will guide you guys how to push that whole project on the GitHub, and you guys can explore. And on the last day I will provide the a sample notebook of this whole project, so you guys have no problem in that. I think. Sir, can you teach ANN, CNN? Yes, everything is going to be there. Have some patience. Like many people are asking how to access Google Colab. You just have to go on Chrome and type Google Colab, and the first link, whichever it appears, it is going to be Google Colab. So So starting from like, okay, so let me first get you the data set which we are going to use. Just a second. Um, I think my screen is again visible to all of you guys. I think my screen is again visible. Okay. So once you guys like, when you go on a new tab, you just have to type Kaggle. Like when you type the Kaggle, you just go, the first ever link which is going to appear is like here, Kaggle, your machine learning and data science committee. So when you go here, you have to like sign in. Like I have already signed in, so I don't need it. So there will be an option right on the top side for sign in. So once you sign in, this is a site where you can find the public data sets, which is kind of even sometimes original or like 90% time a dummy data set, but it actually resembles the real data set, but just the name and some things are more so to maintain the privacy. So in this, we are going to search like heart disease UCI. First of all, you are going to search heart disease UCI, and in this, like when you when you normally search, it will appear like this. Then you have an option of data set here. The fourth option on the top of data set, you have to click on that. So when you click on that, mm, it's taking time. Like it will open like this. When you search heart disease UCI, mm, no, it's not getting good. It should like when you like search heart disease UCI and click on the data set, the first the data set whichever it appears, like here it is made by Redwin Sony. So this is the data set for like now we are going to use, and it contains all these content like ID for each patient and age, origin to train the data. Then we have sex, then we what kind of chest pain type they are feeling, and every type thing related to like I'm not good biology student, so these are kind of things which matters while analyzing the disease. So when you reach here, like when you go on the right top corner, there is a logo of your profile. When you click on that, and then further you have to click on settings. Once you go on setting, you have to scroll down, and while scrolling down, you have to click on create new token. Once you click on create new token, it will create a token and a file will automatically download in your system, name as kaggle.json. It will be named as kaggle.json, which will contain your like token and the key of your ID, which will be linked to the uh, collab. So once you download this file, link of the dataset. Just a second. I will be providing link of the dataset. This is the link of the dataset which you guys are going to use. So if you guys have any doubt, I have pasted in this. Otherwise, also you guys can directly go on the Kaggle and search heart disease UCI, and it will like appear on the top like first ever the link. It has more than 59,000 downloads. So many people have used this. So we are going to use this, and after that you have to go on settings and move down to the API. Here you have to click on create new token. File will be downloaded name as kaggle.json in your download section. I think this much is clear in I think. Okay, so now we will start with this. So like we have already kind of downloaded the file in the system, so we have to upload that file in this. So we will be writing from, if whenever we need to upload a file from a system, we write a code from Google Colab to files, and then we will give files dot, we have to upload a file. So when we run this, an option will come here, choose file. So when you click on that, like if I have already downloaded it, so I will click on that kaggle.json and click on open. So here the file will get downloaded automatically. See here, file will get downloaded automatically. So you just have to like upload that file, and it will like extract the user key and like username and the key of your file system. It is simply like suppose you have to order some food, and Kaggle as a Zomato, so you have to log in your ID. Same way we are doing this, we are importing the like ID and password here, so we can log in our Kaggle directly from the Google Colab instead of like downloading the whole data set, then re-uploading it on like data sets are used. So instead of downloading and uploading, we will directly import that from the website using the API keys. Yes, you have to create a new notebook in the Google Colab. You have to create a new, like last time we have a image recognition, it was a different project and this is a different project, so you have to create a new uh, notebook. So in that you have to write like this, and moving further with this, you have to like set some kind of permissions to the file. So we will give mkd, we have to like set some kind of permissions, and then we will give like we will going to make a directory name as dot kaggle, and in that we are going to copy the file name as kaggle.json which you guys have just uploaded. So here, like this whole, we are going to set the permissions for that file which we have uploaded, and you have to run it. So when the file got run, you will see a green tick in the section next to it. Then moving forward, we will be installing an like package of the Kaggle. No, it is not Anaconda Navigator. It is Google Colab. I'm too fast. Okay, I will try to like slow down. If you guys have to see the code, you can see from here. Okay. Now further moving forward, we will install the package. Like here, we will install the Kaggle. So So now we are going to like directly install the data set from the Kaggle into a code environment of Google Colab. It is like, imagine you want to order food from a restaurant name as Kaggle. So that restaurant is Kaggle, and you need a delivery app like Swiggy or Zomato. Here that pip install, like pip install Kaggle. Here pip install is like installing Swiggy and Zomato on your phone, so you can order that food from the restaurant name as Kaggle to your house. So here your house is your coding environment, your Google Colab. I think people might now understand. Now they can relate what actually we are installing. We are installing a package. Here pip install is just like Swiggy or Zomato. It is a mediator between installing the whole package of Kaggle into your coding environments. So what is actually pip? Like pip is a like pip is a Python package manager. It is just like you can say Play Store or uh, App Store, you can say, where you can download any kind of library or any package which is available globally. Sim and install Kaggle. Like it is telling and instructing Play Store or Apple Store to install that specific application into your system. It is as simple as that. So if we don't like fetch this without the Kaggle package, Python cannot like talk to. It is a mediator, as I already told. So Python cannot talk to Kaggle server to fetch the data sets. So we have to install this, and then we can move forward with this. So once you guys are done with this, like when you come here, like when you come back to this Google, you guys can like see this part. Like either you guys can directly import Kaggle Hub and then download, or you can guys import it as a zip file. So like if anyone has having an internet issue, it can be downloaded as a zip also, so the space can be saved. So I think everyone has got the dataset link, so we can move forward. Oh shit. Just a second. The screen sharing. Is my screen again visible? Yeah, I think again it is visible. So like we will be moving forward with this. So we have to write a code in this to like input the whole data set, and we will like create a new link, and then we have to write this code. Like Kaggle, the data set we have already, the package we have already installed. In that, we are telling to download the data set name as Redwork Sony heart disease data set into the place. Like here we are telling the place in the content disease, and also unzip it. Like we are downloaded it in a zip form, so we are going to unzip also. So once you like run this, it will download the data set, and it has told you downloading dataset dot zip to content heart disease. So like, just a second. So sorry for the break. Let's coming back to this. So we have downloaded the dataset directly from the Kaggle to our coding environment. So here you can see, like when you go on this, you can see the heart disease, and inside that, if you see, they will see the whole dataset in the form of CSV file. So it has directly imported from that. Like when you like here the same as content, when you see in content, it will saved as a heart disease UCI. So in the folder name is heart disease. So coming back to this, once we import the data set from the Kaggle, we will move forward with the further things. So here now we will like analyze. First of all, we will read the data set using the pandas. So now many people here who are new to programming language or anything whole Python, so they will get confused like what is pandas. Uh, Pandas is just like Excel for the Python. It helps, it helps us to work with tables of the data instead of saying see this pandas. In simple language, you can say it is Excel sheet or the sheet which we work upon of the Python. And instead of calling at whole as is like if we use Excel sheet, we it is a Microsoft Excel. So instead of calling whole as Microsoft Excel, we called as short form as Excel. So here we are taking whole pandas as PD. So it can be easily reused again and again. We don't have to write whole pandas dot read or anything. We can directly use PD as a short form of that. Okay, if you guys want link again, okay, just a second. I'm pasting again the link. I hope now you guys have got the link again. So moving forward with this now, here we are importing the whole data set which we have downloaded from the Kaggle into a simple variable known as df, or the data frame we can say. It is pd like pandas dot read csv is a keyword which is used to analyze the whole data set and give it to the uh, and then like load that data set into df or the data frames. it reads the data, heart disease data sets, and store it inside the variable df as a short form for the data frame. And like whenever you open any file, there's it is called as, like when we have to open or like read anything, we use this read.csv file. So now when we move forward with this, we have to, like first of all, analyze, like whenever we have to, like if you have given any task that you have to work upon anything, so first of all you need to like look whole how this whole thing works, what actually we have been given task, so we have to analyze it. So to analyze it, we will write this command df.head. So in df.head is what actually it is actually, uh, let's suppose the whole data set contains more than 50,000 rows and columns. So it is not possible for everyone to like read whole data set and understand what actually thing is. Same way, suppose you have been given a book of 1,000 pages, and you just open the first 5 pages and analyze the first 5 pages and understand what actually book is trying to say, or what the message book has, what actually book is about. So same way, with this df.head, we are going to analyze what actually the data set is. It gives the first 5 rows with all the columns of the data set. So when we run this, see, here it will give all the column, like it has id, age, sex, data set, cp, and much more things. I think all these are bio terms used for the patient treatments. I don't know very much about these terms, what actually these terms means, but they are, I think, related to bio or the diseases. So I don't have much to say about, like we will like understand what actually data set looks like it is giving how much, like women's and male, female, age and everything to the students. So it will like give you an overview, just a small brief overview what the actually data set you are going to work upon. So now moving forward with this, like although we have get all the columns of this, but sometimes some columns are empty and they doesn't get feeded here. So we can like get all the columns also, like we can print the columns, like print df.columns. So when you run this, it will give you all the column, like id, age and everything, like till the num. So here I think, yeah, here also all were given some, yeah, I think every column was given, and data types all also given, that an object data type. So by just looking for the first 5 rows, like here I think every column has values and everything, but we don't know whether the further rows or the columns have any empty value or not, like if there are some missing values or not. So we will have to look about that also, like we have to understand like there are any empty values or not, and if there are some empty values in each column, how many empty values are there. So we will run this code df dot is null, and then we will sum all of them. Is null will tell all the null values, and some will like hold together, return the value that how many empty spaces are present in each of the column. So when we run this, you can see, like in id there are no empty values in data set, but in the test.bp bps and there are 59 empty values. When we talk about cholesterol, there are 30 values. When we have blood sugar fasting kind of thing, I think it has 90 empty value, and so on. Like, this data set is huge, so we have like many empty values. Some are only two, like here numbers are all filled there and some no. So we have understand like what actually these are. So now what we are going to do, it is time 7:45. Don't spam attendance. Yes, or all columns are important for this. Like if you guys are, when you like guys talk about columns, so in the disease, like you can't rely upon a single factor. So like when you, if someone is having a high bp, doesn't mean he will have a very much hard disease. There might be some another factor also related to that. So a number of factors. So you know, like you have studied about probability. So there is probability depending upon several factors, that he is suffering from a heart disease or not. Say, so we can't just ignore any kind of column. So all of them are important. What is different between Kaggle, JSON file, or CSV? CSV is the data set which we are going to use, and Kaggle.json is a simple file which is holding your, like here you can see, when you have loaded, it is just holding your username and key, your password. It is as simple as that, nothing very much like difficult in this. It is just simply using the your username and the key. It is not containing any information about the whole project or data set. It is just an authentication key for the login of your Kaggle into your system. As simple as that. I hope you guys have understand this much thing, and we can move forward. Now we will move forward, like we have analyzed like how many empty values we have, or what all we have in this. So now we will uh, fill those values in the system, so that while training it doesn't suffer any problem or anything. So what this line actually means, you guys, yes, you guys can use any like id. Like you guys can even use Kaggle notebook, Jupyter notebook. You guys do like have a notebook in the VS Code or PyCharm. But as like we are teaching at a global level, so Google Colab is kind of mostly accessible. Like you have to install, like if you have to use Jupyter, then you have to install that Anaconda and everything. Then if you have to VS Code, you have to install libraries and etc. But like Google Colab is a web-based IDE, so everyone is having a free access. So we are using it. So I think we should proceed. Yes. So coming to this, like once we have recognized how many empty values we have, we are going to fill these empty values and move forward. Why we need to like first of all, this line numeric, this line finds all the numeric columns, like number, like ages, cholesterol. Like we have two types of column. First is numeric columns, and second is a string type column, or containing text. Like when you have analyzed the data, see here we have numeric columns like age, id, then test bp. Like here all it is numeric value, then cholesterol and THCL, all these values are in numeric. So we will first of all find all these values which are having an missing, like all the in all these columns, wherever the missing values, we will find in this, and then store their name in the numeric columns. Like numeric columns will store all the places which are having a missing values in this whole data set. So just as simple as that. Like if you guys are having confusion by only numeric values, so if you go to a hospital, you fill a form. There are sections in which you have to fill the numeric values just as number and everything, and a part of that there are sections like name, age, what prior diseases you have. So in that you have to fill that text. So here we are detecting the sections where all the numeric values are missing only. So moving forward with this, so we have another line written here. So what actually it does, it actually fills any missing values in this whole data set in numeric columns with the mean average of that specific column. Like if I'm talking about any column of age, like is this whole data set consists of which kind of age. Like here if I'm taking average like 63 plus 67 plus 67, then 37 and 41, we will do an average of whole this age section, age column, and we will fill that mean in all the empty places where that is present. Or here also, like these values also, we will average all of them and fill in that section. So when we run this, it will like automatically fill all the empty values or spaces in the section, and then move forward. Like it will have all the numeric value. Like in now many guys must be having question why we are leaving then the text values. Like they are it has stored some text values are also empty, like which rest ecg. Like in rest ecg also we are having two values as empty. Then what other we have, then we have like slope. In slope how many we are having, like 309 missing values. But we are not going to fill here because we can't do mean of the like text. We can obviously find the whichever mode is the, like we have three things, main, median, mode. We can find the mode and then we can fill, but it is not feasible. So we only perform this function on the numeric columns. We will fill out all the places. So now moving forward with this, we are now going to look how the data on which we are working is looking like. So we are going to import libraries for the data visualization. I think it's almost time for the attendance. Just a second, I will paste the attendance link. And so attendance link will soon come in your chat box. Don't spam. Yeah, attendance Kaggle link has been shared earlier. Attendance link will be shared soon. Just a minute or two. Just a second. So yeah, I've pasted the attendance link. You guys can access from here. So now we are going to move forward with data visualization. Yes, the session will be recorded and it will be available on YouTube. You guys can, if you guys have like missed any section, you guys can recap it again and again. Okay. So now we will, once you guys are done with attendance, just tell so we can move forward. Uh, okay. I think attendance done. Done. So okay. Now we will proceed with the data visualization. Like till now, whatever we have done with the data set, like we have initialized it, that we have looked upon the missing values, the head, and what types of column and everything. So now we have to look upon the data set through the visualization. In this visualization, we like visualization kind of help you to understand or what actually data looks like. So suppose you have been given a task, any task, but you have been just given a theory to do that work. Like suppose any chemistry practical, you have been taught practical with the help of theory that you have to do this, and you go on. So I think very few will understand what actually it is trying to say. So when instead of that, if your teacher brings you to the lab and perform all the tasks, so you guys will have a better understanding of that. Same way we are going to visualize the data, how actually the data looks like, how it is correlated, how each and every column is correlated with other columns, how much they are interrelated and everything. So we are going to look all of this. Yeah, simple example as one given, like if instead of like running code here or doing the programming live, if I would have just given told you to do this, like you have to do the data processing, and then we have to train model, and then you have to hyper tune, hyper parameters tuning and everything, and then you have to deploy, you guys will have not understand. Whereas if I'm doing it live in front of you, you guys are understanding what it actually means. So sorry, so I pasted the Google Form link. So now we will proceed with the importing of the libraries like matplot library and give it as a nickname as a PLT. Same way like in pandas we have given as PD and then data frame as DF. Same way here we have imported the library matplotlib and given it a name as PLT. And again, we have imported another library as a Seaborn as SNS. Now, many guys must have confusion that what is Matplotlib and what is Seaborn. Like both are used for visualization, but there is a difference between them. Suppose matplotlib as a simple brushes for doing a painting, like simple you can take visualization is a painting which you have to make, and matplotlib is simple brushes which you can use to like do any make any painting or anything or do anything. But when you move to the seaborne, it is a kind of fancy paints like oil paints and everything, and like which you can make more make like which can make your data set or the visualization more stylish, more fancy with beautiful colors and themes and etc. So Seaborn is kind of a advanced version of visualization, whereas Matplotlib is a simple visualization library which can have a plot and everything in this. So we are importing both of them together. So Matplotlib simply like builds a graph and like it simple draw graph and everything, charts, then plots, like all the type of graphs are used with the matplotlib, whereas like heat maps and everything are done with the seaborn. So we have to like import this, we have to run this. Once we run, a green tick appears next to it. So we will move forward with this. Now we will visualize what actually we want. So we will first of all plot the types of graph which we want. So in this, we will create a histogram for all the numeric columns in the data set. Like here, we will paste like for DF, as I already told, we are have load data set in this, and the numeric columns, all the which we are having in this, we will plot a hist is a short form for the histogram, and we have given a figure of what figure we actually want. So like fixed size set the like 15 is the width and the 10 is the height, so the like plot doesn't get squeezed very small or a lot bigger size. We have specified the size also, like what size actually we are going to have. Then we have written like plt dot, as you know plt we have given the short form to the matplotlib, plt dot tight underscore layout. So it is actually we have used is adjust the spacing between the plots so they can, so they do not overlap. Like if I have plot, like we are having different types of columns like id, age, and many more things in the numeric values only, so it doesn't get overlap or it doesn't get squeezed. So we have placed a proper tight layout next to each other. And then we have a simple command as plt.show. It will present all that graphs in front of this. Since like now we are going to run this, and once we run this, see all the chart of that like id, age, test vsp, cholesterol, TH, old peak, num, ca, and everything got plotted here. So like when you go in the field of data analytics, data scientists, people have to visualize all that data. Like in that field, like when you go to data analytics, many people you have listened about power bi to live results, see all the live data in the form of visualization. Same way you can like do in the data scientist as a visualization using the python also. Like python can be used to create whole data sets, from visualization to training, and then deployment also in a front end part. Like we can use python to deploy the whole project on the streamlit also, where you can build a simple clean interface which can be used to interact between the users and your system. So see, as I already told you, matplotlib is a simple brushes. So here you can see simple graphs, histograph plotted here. So now we are going to work with the what seaborn, like which I have told is the advanced version of the matplotlib. So here you will see like we can do with heat maps and everything. So when we go here and write a code, we have sns.heatmap. Then we are again correlation. We are forming a correlation between the numeric columns, the columns which we have plotted earlier. So in this, it will create a heat. Do you guys understand what is actually heat map? Do you guys have any idea of heat? What is heat map? So heat map actually shows that darker the heat map, the color of the column is shows the how dense the relation is. Same way we are forming a heat map showing the how strongly numeric values, like numeric feature columns and everything are related to each other. In like simple words you can like understand, imagine you want to check which exam subjects are connected to, do students have to score well in like maths, usually score well in physics too. Then correlation tell us that the heat maps is like a friendship matrix. The darker the color, the stronger the friendship it is. Like it will show the high correlation. The as the color increases, it will tell what kind of uh, relation or what kind of the correlation they have. So when we run this, so I think this command you can like understand, like plot the title, numeric feature collection. We have plotted title and everything. See here you can see multiples, as I was telling you that matplotlib is a simple, if you guess get it a take it as a simple uh, brushes. So Seaborn is a kind of advanced version with like advanced colors basics. Like here you can see all the like everything is correlated to each other, presenting a value of highest correlation. Like one here correlation bar is also presented, like whichever is the has the lowest correlation and whichever has the highest correlation. So id, the diagonal bar graph, this shows that whole of that is correlated with each other. I hope everyone understand this much. So yes, this is how the heat maps look. Yes, it is usually measured between 0 to 1, but we can also get in negative value also. So to understand whether some of the like blocks or some of the columns, some of the rows are kind of less correlated. Like if you see these opposite corners, they are kind of least correlated. And whereas you can see this diagonal, it is the most correlated. It is showing the peak value, the darkest color. I think why do we get it in negative? So in negative we get it because we can understand what value we do not have to take, like in what relations we do not have to take in, so that like the things which are or not correlated, and we are taking that as a primary correlations. So it is not very much good. So we want to take only the most correlated part or the most darkest, like you want your best friend to be with you instead the normal. Like we have several people which we talk every day. Like we have, if you have 10 friends, out of that 10 friends there is only always one friend you call it as a best friend. So you want him to be by your side every time. Same way here also, that best we are talking about, so that the best correlation we can find about between the all the columns. So for today we are done till here. Tomorrow we will continue with day two. Like we have done till here in day one, and in day two we will do the model training and the evaluation of that model. Like we will first build a basic model, and then we will evaluate its like how it is going to do, how it is performing or anything. And if like I hope many students are from last bootcamp also, in which we have developed an image recognition model. So like in that we were using a CNN, and CNN is a kind of heavy uh, algorithm you can say. So but in this we are not going to use that. It has a simple data set with rows and columns, so it is not going to take very much time. So you guys can like have a chill at, it's not going to have very much load on that. So I think we are going to end this today's bootcamp here, and then we will connect with you guys tomorrow at the same time. Till then, I am staying here for 5 minutes. If you have any data set, link is already given on the top in the initial only I've given. I'm going to paste it again. So if any guys have missed which data set we are using, so she can have. See, I've given again the data set. GitHub repository link. You guys only will like on the day 5. I will side by side guide you all. So how to like uh, push or hold this uh, project on GitHub so that it can be deployed and it can be used in your portfolio. You can like showcase the recruiter like what you have developed throughout this time. So any more doubts? Mm, yes, we will be continuing with this project tomorrow. We will train first of all model like we have done kind of preparation today. Uh, Suppose we are going to cook a cake in 5 days, and in day one we have looked upon the recipe which we are going to work upon and everything we are going to have. Like suppose if you are going to have anything, so what kind of recipe you are going to work, it is just telling that. So what you guys have any doubt? The data set is from Kaggle, yes. So any more doubt? What is difference between 0.27 gray color and the least related 0.4? It just simply show that it has a very less correlation, like it doesn't have a very good bond with that data set in correlation to that. Hmm. Simple as that. Like when we have a like let's take an example of any data set with the like zero point 0.7. Here IDE and num with 0. We have a 0.27 correlation. Like they are dependent on each other. Like if it is greater than 0, it has like they are some kind of use. Like suppose in your college you have some people you don't like to talk, so they are rated as 0. Minus 0.44, and there are some people who you like occasionally talk or kind of understand and have a bond with them sometimes, not on a regular basis, so you rate them as 0.27. But the people you like you always get up in the morning and ask, yes bro, are you coming to the college, then only I will come. So we you rank them as one, as a darkest correlation. Simple as that. Okay. On Kaggle showing error, you have to like load again. There might be some server issue. You have to like load again, it will definitely show. If still you guys have any problem, you guys can connect me with on LinkedIn. Otherwise, we will like have just of 4 days. We will get again back to this. Like tomorrow also, we will have a very quick recap in just 2 or 3 minutes of whole what we have done today, and then we will move forward. So let's end today's meet. I think like ends today's session. We will catch up tomorrow at the same time, and I hope to see you all of you guys uh, with the same energy and the enthusiast you guys are showing. So thank you, and let's see you all guys tomorrow.